Imagine finding, like, your absolute dream job on a community Slack channel. You ace the coding test, and in doing so, you silently hand a North Korean hacking syndicate the keys to your company's entire software supply chain.
Yeah, it is terrifying. If you're a developer or if your company employs them, your day-to-day workflow is currently the target of this highly sophisticated state-sponsored trap.
And it completely bypasses traditional security thinking, right? Like, we
Yeah.
aren't dealing with a malicious email attachment from some unknown sender here.
Yeah, not at all. Or a shady download link. The delivery mechanism is, well, it's fully camouflaged as career advancement.
Right. So our mission today is to decode exactly how an innocent-looking job interview can silently hijack a developer's system. To do this, we're looking at a threat intelligence report from Elastic Security Labs that was featured recently in the Hacker News.
We also have this incredibly revealing attack flow diagram sitting right in front of us, mapping out the execution step by step.
It's wild. The subject here is an ongoing operation known as Contagious Interview. It's run by North Korean threat actors tracked as REF 9403 and UNC 699.
And I mean, this isn't just a flash in the pan. The operation has been highly coordinated and actively ongoing since at least December 2022.
Wow, that long?
Yeah. The fact that it remains so active, using nearly identical social engineering tactics years later, it just speaks volumes about how effective the strategy really is.
Okay, let's unpack this. The initial contact doesn't happen on the dark web or some, I don't know, obscure hacker forum, does it?
No, it happens in the brightly lit, heavily trafficked public squares of the tech world. Specifically, community chat platforms where developers usually feel safe.
They're leveraging environments where trust is the default currency. Look at late May of 2026. Picture a bustling, legitimate community Slack workspace.
Right, filled with thousands of developers sharing best practices, networking, just looking for new gigs.
Exactly. And in the designated jobs channel, a user going by the name Maxwell posts a very detailed job opening. And this post is incredibly realistic.
It's not generic spam promising easy money. The listing asks for an experienced developer to help upgrade an e-commerce platform.
And the tech stack it calls for is so specific. It wants a modern, scalable architecture using Next.js version 14, Nest.js, PostgreSQL, and Auth.js with Stripe integration.
See, the specificity of that stack is what instantly legitimizes the recruiter. A generic scammer typically, throws together buzzwords that just don't quite fit.
Right, like asking for Java and HTML as if they're the same thing.
Exactly. But specifying Next.js version 14 alongside Auth.js and a PostgreSQL backend, that proves the person posting actually understands modern web development.
So to a developer, there are absolutely zero red flags. It sounds like a totally standard, well-architected e-commerce build.
Right. A developer sees this, recognizes the stack, and expresses interest. And that triggers the psychological pivot.
Maxwell takes the conversation out of the public channel and moves it into direct messages. From there, they ask the applicant to complete a standard coding assessment.
Which is just a Trojanized GitHub repository that contains the required files. What's fascinating here is the sheer persistence and patience of this approach.
They really play the long game.
They do. Daniel Stepanek, a threat research engineer at Elastic, points out that these threat actors don't just create an account and immediately start spamming malware.
They take the time to build a credible reputation first. On Slack, Discord, GitHub, LinkedIn, Telegram, you name it.
Impersonating real users or brands, ingratiating themselves into the community before they actually strike. Victims run the challenge, feel something is off, and suddenly the recruiter just vanishes.
But I have to push back on the mechanics of the trap itself here, because developers aren't naive when looking at code.
Sure.
If the code in this GitHub repository is fully functional, how is the malware getting onto your computer without triggering massive alarms? Like, why doesn't the antivirus flag an executable?
Well, the answer lies in a highly refined technique called steganography, which is the practice of hiding malicious code in plain sight, specifically inside files that inherently shouldn't be dangerous or executable. The payloads aren't sitting in an executable file. They are hidden inside image files.
Wait, I understand hiding things in images, but an image file, like a standard JPEG or PNG that doesn't execute code, it just displays pixels.
That changes when the attackers use SVG files, scalable vector graphics.
Okay.
They disguise the malware as images of country flags, naming the files things like ae.svg or af.svg, and they just place them innocently inside an assets directory.
And an SVG file isn't made of a grid of pixels, is it?
Nope, it's actually built on XML code. It's a markup language that instructs the web browser on how to draw the shapes and colors mathematically.
Because it's essentially a text file containing markup code, you can inject non-rendering elements into it without breaking the actual image.
Precisely. The XML structure is the perfect hiding place. In this attack, the payloads are split up into tiny fragments, encoded in base 64, and tucked inside standard HTML comments within the XML code.
By using base 64 encoding, they make sure the script doesn't look like executable JavaScript to an antivirus scanner. Base 64 translates binary data into a string of 64 standard ASCII characters.
Right, so to a security scanner, it just looks like a random string of alphanumeric text,
Yeah.
maybe a benign session token or application metadata, just sitting harmlessly inside a comment tag.
The scanner sees a picture of a flag, sees a text string in a comment, and just moves on.
It bypasses detection entirely. The payload remains totally inert, just resting inside an image until the developer takes action.
Let me offer an analogy for you listening. It's like receiving a beautifully painted, complex jigsaw puzzle in the mail as a gift. It looks totally harmless, and the painted surface is flawless.
I love this analogy.
But the actual poison is carved into the microscopic wooden tabs of the puzzle pieces, written in a foreign language. You can inspect the individual pieces all day and never get hurt. You only get poisoned when you snap the puzzle together.
Exactly. And the assembly of that puzzle happens the moment the victim is ready to test their coding challenge locally. They open their terminal and type a standard developer command.
The classic npm run dev.
Yeah, npm run dev.
Which is pure muscle memory for a web developer. It just tells the machine to start up the local server so they can preview their code in a browser.
In a normal project, sure. But in this Trojanized repository, running that command executes a seemingly normal JavaScript file called servervalidation.js.
And that script acts as the assemble. It silently sweeps through the assets directory, locates those SVG flag images, extracts the base 64 fragments from the XML comments,
Decodes them back into executable code, stitches the fragments together in memory, and executes the malicious script entirely behind the scenes.
and because it's tied to that npm run dev command, the malware is reassembled and executed every single time the developer boots up that server to work on the project.
Right, the persistence mechanism is built directly into their daily workflow.
So now that we know how the puzzle assembles itself, what exactly is it unleashing? Looking at the attack flow diagram provided by Elastic, it triggers a massive multi-stage payload.
Once it executes, it unleashes a highly sophisticated family of malware known as OtterCookie.
OtterCookie.
Yeah, Microsoft has actively tracked the evolution of OtterCookie since September of 2024. It began as a relatively basic tool for executing remote commands, but it has evolved into a highly modular, evasive threat.
The diagram shows that before it even unpacks its main weapons, OtterCookie runs a series of checks to see if it's operating in a virtual machine environment. How exactly does a script figure out it's in a VM, and why does it even care?
Well, security researchers analyze malware by trapping it inside sandboxed virtual machines. To counter this, OtterCookie queries the host operating system for specific artifacts.
Like what kind of artifacts?
It checks the MAC address of the network adapter to see if it belongs to known virtualized hardware, like VMware or VirtualBox. It might also query the Windows management instrumentation to look for specific hypervisor drivers.
Oh, wow. And if OtterCookie detects those artifacts?
It plays dead. It simply stops executing to avoid giving researchers a clear look at its behavior.
That's incredibly smart. So assuming it's running on a real developer's machine, it gives the green light, and the diagram shows it branching out into 5 distinct prongs of attack.
Yet 5 specialized modules.
What strikes me isn't just the sheer number of backdoors, it's how specialized they are. It's not one blunt instrument grabbing everything and firing it back to a single server.
Right.
The wallet stealer calls out to one command and control domain, while the browser stealer goes to a completely different one. Why partition the architecture like that?
Partitioning the data exfiltration makes the malicious traffic blend seamlessly into normal application behavior.
Ah, I see.
If a single background process suddenly starts firing gigabytes of mixed data like passwords, source code, and cryptocurrency keys to one random IP address, network monitoring tools will flag the anomaly immediately.
So by breaking it down, each prong acts like its own microservice. Let's walk through those specific modules. Prong 1 is the wallet stealer, targeting cryptocurrency.
Which connects to a specific endpoint. State-sponsored actors from the DPRK are notorious for plundering crypto wallets to fund their broader operations, so prioritizing financial theft makes perfect sense.
Prong 2 operates concurrently. The browser stealer harvests web credentials, saved passwords, and active session cookies, securing the keys to the victim's broader digital life.
Exactly. Then prong 3 is the file stealer, pointing to an upload endpoint.
And we will come back to the specifics of that file stealer in just a moment because the extensions it targets are incredibly revealing.
Oh, definitely.
Prong 4 is a clipboard stealer. This means any sensitive information you temporarily copy and paste. An AWS API key, a secure message, a two-factor token, it's captured and transmitted the moment it hits your clipboard.
It's terrifying. And then the fifth and final prong secures long-term dominance over the machine. It's a socket.io backdoor.
But socket.io is a completely legitimate library, right? Used to build real-time web applications like chat interfaces or live dashboards. Using it as the infrastructure for a remote access Trojan or a RAT is brilliant camouflage.
Yeah, the attackers are leveraging WebSockets. Unlike standard HTTP requests that, open and close instantly, WebSockets keep a persistent two-way communication channel open between the client and the server.
So by utilizing socket.io for their command and control, they blend their traffic with the exact type of real-time data flow you'd expect to see on a web developer's machine anyway.
Exactly. This RAT grants the attackers persistent remote control. They can drop new executables, browse the file system, or run arbitrary shell commands long after the fake interview concludes.
Here's where it gets really interesting, going back to that third prong, the file stealer. The Elastic report lists the highly specific file extensions that AutoCookie is programmed to hunt down.
It isn't just looking for standard Word documents or Excel spreadsheets.
Right. It is specifically gathering files ending in .claude, .cursor, .gemini, .windsurf, .peri, and .llama.
Yeah.
Why go through all this trouble to target artificial intelligence coding extensions? What is the strategic value for a North Korean hacking syndicate to hoover up this specific type of AI data from a random developer?
Well, if we connect this to the bigger picture, the threat actors are actively refining their arsenals based on how modern software is actually built today.
Because developers increasingly rely on AI tools like Claude, Cursor, and Gemini to generate boilerplate code or troubleshoot proprietary algorithms.
Exactly. To manage complex system architectures. When a developer uses those tools, they frequently paste massive blocks of their company's source code, internal documentation, and sometimes even API keys right into the AI's context window to ask for help.
Oh man, so stealing those context windows gives the attackers an unrestricted view into the proprietary logic of the companies those developers work for.
They aren't just stealing code. They are stealing the developer's thought process. They can see what systems are being built, how they interact, and, critically, what vulnerabilities might exist in that specific code base.
But the Elastic report suggests the endgame goes even further than stealing proprietary code from a single employer. Earlier this year, this same threat group, UNC 2069, was observed creating a fake Slack workspace to invite the maintainer of the Axios NPM package to a bogus meeting.
Yeah, Axios is a massively popular JavaScript library used by millions of websites globally. The developer is just the doorway. The actual target is the entire software supply chain.
Elastic's warning in this report is stark. Developers remain a prime target because compromising just one highly placed individual provides the initial access needed to launch a catastrophic, far-reaching attack against downstream organizations.
Yep.
To put that in perspective for you listening, imagine a city's water supply. Breaking into a downstream user system to steal their credentials is like breaking into an individual house to poison their tap.
It's effective, but the damage is limited to one target.
Right. A supply chain attack is like poisoning the main water reservoir. If you compromise a developer who maintains a widely used open source library or who has commit access to a major corporate repository, you infect the code they publish.
Thousands of downstream organizations download that routine update, and the attackers gain access to all of them simultaneously. The success of operations like Contagious Interview proves that state-sponsored actors view the developer community as the most efficient vector for massive organizational impact.
So what does this all mean? We've traced a path from a highly believable tech stack requirement in a community Slack channel to an innocent-looking direct message.
To base 64 fragments hidden inside the XML tags of SVG flag images, silently reassembled by a simple npm run dev command.
We watch AutoCookie evade virtual machines, partition its traffic to dodge network monitors, drain crypto wallets, establish a socket.io backdoor, and systematically hunt down AI coding contexts, all to lay the groundwork for poisoning the global software supply chain.
It's a total system compromise hidden behind a job interview.
The architecture of this attack forces a harsh reality check. We operate in an industry where developers are aggressively encouraged to hustle.
Right. You're told to collaborate openly on open source projects, network continuously on platforms like Slack or Discord, and enthusiastically take complex technical assessments to prove your worth and advance your career.
That open exchange of ideas and collaborative spirit is the absolute foundation of the modern tech sector.
But the very mechanics of career advancement and community collaboration are being weaponized against the people driving the industry forward.
When participating in a trusted community becomes the primary vector for state-sponsored espionage, how do we redefine trust in the tech industry?
We're looking at a future where we may need to fundamentally change developer psychology. Are we entering an era where we have to treat every new career opportunity, every recruiter direct message, and every repository clone as a potential hostile entity?
It's a chilling thought to leave on, but an absolutely necessary one. You can't just rely on antivirus software when the attack is engineered to look exactly like your daily routine, bypassing scanners by hiding inside the very tools you use to build the web. Thank you for joining us on this deep dive. Stay curious, double check those file extensions, and above all, stay vigilant out there.